Let's start with a very common architecture. We have a backend API, and it connects to a Postgres database on startup. Here is the problem. The Postgres container starts very fast, almost instantly, but the database itself becomes ready to accept connections only after a few seconds. Docker sees the container as started, so the backend container starts immediately. The backend tries to connect to the database, connection refused, the backend crashes, Docker restarts it, and we got an infinite restart loop. So the question is, why does that happen? It happened because in our compose file we used only depends on keywords. As we remember, depends on give us only startup order. So when we write in Docker compose depends on db, it means that at first we need to start db container, then we can start our application. Docker started the database container, but Postgres itself is not ready yet. This is a key idea. A container being started doesn't mean the service inside is ready. To save us from crash, we can use healthcheck. The database now has a healthcheck, and the backend waits for the database to become healthy, not just started. As you can see, here we use a special command that shows us if DB is ready. Also, we can set timeout of this command, different retries and interval for this command using. Now the backend will wait for the database readiness, not just the container startup, but for the service is actually to be ready. So now let's make sure that it works. And it works just fine. Firstly, we set up database, we check that it works, and now our application can start without any errors. Now let's talk about image optimization. If your image weighs gigabytes, that is not normal. If it builds slowly, that is not normal either. Image optimization is not about aesthetics, it's about speed, money, and stability. Here are some tricks that really can help us. So the first tool is Docker Ignore. By default, Docker sends the entire project directory into the build context. That includes Git history, virtual environment, node modules, logs, datasets, everything we actually don't need. Docker doesn't know what you need, so it just takes everything. Here is a small example of how it looks. The second thing I would love to remind you is Docker cache. As you remember, every command in Docker file is a specific layer. So the rule is simple. If this layer is rarely changed, we can use it higher. And if it changes a lot, we can use it lower in our Docker file. The next thing I would really love to focus on is multi-stage building. One of the most common Docker mistakes is building one image for everything. For building, for running, for production. And in the end, production contains everything we don't need. To understand the idea more clearly, let's use Golang example. In Go, we usually compile the program, and as a result, we have a binary file that we can execute. And now ask yourself, do we really need to copy all this code we have to image? Of course, no, we need to have only the binary file which we can run. So the solution is to make two stages. The first stage where we can build our program, and the second stage where we just run our final program without code, without dependencies. So now let's make a small test. Here we have a small application. We just print hello from Go. We have some requirements, we have some dependencies, and we have an average Docker file with only one stage. And also we have multi-stage Docker file. Here in the first stage, we're just making executable file. In the second stage, we are pulling the smallest image we can. We copy the executable file from the first stage and run it. Now let's see what these tricks give us. We are building two images using different Docker files. Now it's time to compare our two images. As we can see, the difference is huge, it's about 10x. Just imagine how helpful this trick could be in production, where you could have much more dependencies. This trick is also useful in other languages like Python. For example, here we also have a small application and we got huge requirements, like really huge. So it's definitely a good case to multi-stage Docker file. In the build stage, we install dependencies into root local. This directory is not part of the system Python. It's just build artifact. So we don't copy Python, we don't copy pip, we don't copy different compilers from dependencies. We copy only the result of the build. Here you can see the result. It's not as cool as in Go, but it's definitely worth it. The last thing I would love to mention is Docker cleanup. Even with perfect Docker files, the system will slowly rot. Stopped containers stay, old images, volumes, build cache, and one day you're definitely gonna see no space left on device. These two commands really can help you. The first one will show you disk usage, and this removes unused containers, images, networks, and cache. But be careful, with great power comes great responsibility.